Okay, yeah, I'm not lying today. It's really the easiest thing we're going to do. Okay. Okay, here we go. So, if we talk about the set of all numbers, all the numbers are called complex numbers. And the complex number has a real part and an imaginary part. And the real part is the A, and the imaginary part is the B. It is. And under the real numbers, we have rational and irrational. All right? And so all we're going to talk about today is the rational numbers. We're going to talk about rational answers. So the rational root theorem is going to give you all possible real roots of a polynomial. Descartes' rule of signs is going to give you the number of possible positive and negative real roots. So the rational root theorem is going to give you the possible real roots, and the rule of sign is going to give you the number of positive and negative. Okay, so here's what you need to know. What, you really need me to go back? So here's what you need to know right here. So for the rational root theorem, it's going to be P over Q. P over Q. P is going to be the constant factor. So P, girls, P is the last one, whatever the last number is. And P goes on top. Q is the leading coefficient, and it's going to go on bottom. And so this is how it will look. What is the leading coefficient here? 2, and Q is the leading coefficient. And the constant term is 5. So to find the total number of factors, we want the factors of the constant term divided by the factors of the leading coefficient. And when I do this, we don't know if it's a positive or a negative, so we're going to have both. So I'm going to list the factors of the constant term. So what are the factors of 5? 5 and 1. So I'm going to have plus and minus 1 and plus and minus 5. The factors of the leading coefficient, 1 and 2, right? So to get the possible roots, we're going to ignore the 2 to start with. So I'm going to take 1 divided by 1, and that gives me plus or minus 1. 5 divided by 1 gives me plus or minus 5. And then cover up the 2. The 1. Plus or minus a half. And plus or minus 5 halves. And that's the possible set of solutions for that polynomial. That's it. I told you I didn't lie today. It really is that easy. So, 10. So we're going to have plus or minus 1, 2, 5. Yes. And right. And what's the leading coefficient of this? 1? Okay, so what goes on bottom, Isaac? Okay, listen, what goes on bottom? The Q, and Q is the leading coefficient. And what's the leading coefficient this time? 1. So P is here and Q is here. Every time. What's the leading coefficient? What are the factors of 2? Okay. So the factors of 8. 1, 2, 4, and 8. And the factors of 4. 1, 2, and 4. So my possibilities? Always. No. No. And you might, some of your friends might do it. We're not doing that. You write it this way because that's how this works. So I'm going to ignore the 2 and 4, and I'm going to have plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And then I'm going to the 2. Plus or minus a half. Now, what's 2 divided by 2? I already have it, so I don't have to do it again. 4 divided by 2 is, I already have it, and I don't have to do it again. 8 divided by 2 is 4. I already have it, so I don't have to do it again. So I'm going to go to the 4. So I get plus or minus 1/4. 2 divided by 4 is a half. I already have it. 4 divided by 4 is 1. I already have it. 8 divided by 4 is 2. So I'm all done. So which one goes on top, the constant or the leading? Constant on top, the leading goes on bottom. Okay. So when we were finding the number of roots, okay, listen or you're not going to get this. When we were finding the number of roots, we had a plus and a minus, right? So each root has how many possibilities? 2, the plus and the minus. So for this, whatever I get for an answer, if I start at 6, then I'm going to also have 4, 2, and 0 for an answer. Like I'm going to have to count backwards by 2, whatever my answer is. Counting for the 2 answers, okay? If I started at 5, how many possible answers would I have? 5, 3, and 1. Okay? So if I start at 3, I'm going to just have 3 and 1. Okay? Does this make sense? If you have 2, you'd have 2 and 0. Subtract 2 from however many you start. Just subtract 2 until you get to 0. Does that help? All right. Oh, my gosh. Okay. So what we're doing now is this test tells you how many positive and how many negative answers you're going to have. How many positive and how many negative. And this is how it works. I'm going to do this twice. So what I want to do on the first one is I'm going to test a positive x. So is anything going to change over here if I put a positive x in here? No. No. A positive, nothing changes. So what's the sign here? Positive. What's the sign here? What's the sign here? Okay, so write that down. What this theorem tells me is the number of changes in the sign, that's how many possible positives I'm going to have. So the sign goes from positive to negative here. So that's 1, 2, 3, 4. So I could have 4 positives or 2 or 0 positive roots. So watch. How many times did the signs change? 1, 2, 3, 4. So I can have 4, 2, or 0 positive roots. Because you subtract by 2 each time. No. It's positive because we did a positive x. So tell me where you're getting your fifth sign change. Because this stays positive, so the signs don't change. All right, let's try it again with a negative x. Maybe you'll have better luck this time. So watch. This time I'm going to write this out. I'm going to write it out the first time so you can see, but you won't have to write it out after this, okay? But watch so you see what I'm doing. I'm going to take this negative x and I'm going to put it in wherever I see an x. So okay, that's what I said. You're not going to have to do this every time, but I want you to see what I'm doing. So, what is negative x to the 6th power? Is that a positive or negative number? Positive. Negative x to the 5th power is negative, and so what's negative times a positive? So that one's negative. Negative x to the 4th power is positive. Positive times a negative is negative. Negative x to the 3rd power is negative.
No, it'll be, wait, you talking about negative x? Oh, yeah, it's positive. Look, man.
Negative, positive, negative.
Negative, positive.
I know. So I lost track where we were. Positive, negative, okay. So this one is negative. Oh, hallelujah. But it's positive times a negative. And the last one is positive because there's no x, so it doesn't change. So how many sign changes do I have? 2. So I can have 2 or 0 negative roots. Oh, thank God. Right. Yes. So try the next one yourselves. You're going to do 1 positive and 1 negative. Oh, yeah, 5. No. Yeah, just do what's here. If you can do it in your head, you just do it in your head. All right, let's do it. So the first one is three or one positive roots. Okay, I didn't. I said you go by evens. So if I subtract 2 from that, I get negative 1. Is that a possibility for a number of roots? Oh, no. No. So the evens, you'll go to 0. The odds, you'll go to 1. All right, so the negative. Okay, how many of you are understanding now? Oh, thank heaven. You guys got it? Did you get it? Yes? What? Wait, this one? Because negative x to the third is negative, but a negative times a negative is a positive. You get it? Yes? You get this? All right. Shh. Okay, last one. Okay, not right now, you're not. We're taking notes. So I'm going to have positive, negative, negative, positive, negative, positive. So 1, 2, 3, 4. So I'm going to have 4, 2, or 0 positive roots. It's algebra 2. So the negative, if I put the negative in, the first one is negative. The second one is negative. The third one is positive. Positive. 1. So I can hit 1 negative root.